Hamel Engineering, your sustainable power solution. Solar photovoltaic raw component. In this video, we will discuss about basic component of solar photovoltaic or PV raw component. During this lesson time, we will learning about raw material that used to make a PV panel in detail. Let me start from this question. What is the raw material that composes a photovoltaic module? Have you ever wondered what is the structure of a photovoltaic module and what are the main materials? There are many solutions available on the market and many raw materials that can be found, but the philosophy for manufacturing a solar panels is the same for everyone. If we try to describe in a few words the structure, we could say that a photovoltaic panel is composed by a series of photovoltaic cells protected by a glass on the front and a plastic material on the rear. The whole of it is vacuum encapsulated in a polymer as transparent as possible. Let's focus now on the single components more thoroughly. Photovoltaic solar cell. Cells are the main component and have the function to capture the sunlight and convert it into electricity. Crystalline cells can be monocrystalline or polycrystalline, according to their manufacturing process. This, however, does not affect the PV module production process. The main technical characteristics are size, color, number of busbar, and above all the conversion efficiency. Solar cell structure. A solar cell is an electronic device which directly converts sunlight into electricity. Light shining on the solar cell produces both a current and a voltage to generate electric power. This process requires, firstly, a material in which the absorption of light raises an electron to a higher energy state, and secondly, the movement of this higher energy electron from the solar cell into an external circuit. The electron then dissipates its energy in the external circuit and returns to the solar cell. A variety of materials and processes can potentially satisfy the requirements for photovoltaic energy conversion, but in practice, nearly all photovoltaic energy conversion uses semiconductor materials in the form of a PN junction. Let me show this one in detail. Basically, solar cell consists of a layer of P-type silicon placed next to a layer of N-type silicon. In the N-type layer, there is an excess of electrons, and in the P-type layer, there is an excess of positively charged holes, which are vacancies due to the lack of valence electrons. Near the junction of the two layers, the electrons on one side of the junction, N-type layer, move into the holes on the other side of the junction, P-type layer. This creates an area around the junction, called the depletion zone, in which the electrons fill the holes. Encapsulate material. One of the most important materials is the encapsulant, which acts as a binder between the various layers of the PV panel. The most common material used as an encapsulant is EVA, ethylene vinyl acetate. It is a translucent polymer sold in a roll. It must be cut in sheets and deposited before and after the photovoltaic cells. When subjected to a thermal process of vacuum cooking, this particular polymer becomes similar to a transparent gel and incorporates the photovoltaic cells. The quality of this process, called lamination, ensures a high service life to the module itself, while the encapsulant quality affects the light transmission, the process speed, and the resistance to yellowing due to UV rays. Front glass. The front glass is the heaviest part of the photovoltaic module, and it has the function of protecting and ensuring robustness to the entire photovoltaic module, maintaining a high transparency. The thickness of this layer is usually 3.2 millimeters, but it can range from 2 millimeters to 4 millimeters depending on the type of glass chosen. It is important to pay attention to features such as quality of hardening, spectral transmittance, and light transmittance. For photovoltaics, some special glasses have been studied with a special pattern on their surface, ensuring a greater degree of light trapping. Choosing carefully the glass, checking these features, or adding anti-reflective layers can bring an overall improvement of the efficiency of the module. Junction box and backsheet. The junction box has the function of bringing the electrical connections of the PV module outside. IT contains the protection diodes for shadows and the cables for the connection of the panels in the field. In choosing the junction box, we pay attention to the quality of plastic. the goodness of sealing, the type of connection of the ribbon, and the quality of bypass diodes. Diodes, or integrated with microinverters, were born. The price of these solutions has not yet allowed a mass distribution, although the potentiality is interesting. Backsheet. The term backsheet literally means the sheet on the back. It is made from a plastic material that has the function to electrically isolate, protect, and shield the PV cells from weather and moisture. This particular sheet is usually white in color and is sold in rolls or sheets. There are particular versions that can be different in thickness, in color, and in the presence of particular materials for a greater shielding or for a higher mechanical strength. Frame. One of the last parts to be assembled is the frame. It is normally made of aluminum and has the function to ensure robustness and a practical and safe coupling to the photovoltaic module. Together with the frame, also a layer of sealant is deposited around the walls of the panel as a moisture barrier. For this purpose, the most widely used material is silicone, although sometimes a special sealing tape is used. Please make like and subscribe for more video. Thanks for watching.